So the next logical step when we're looking at offset voltage might be to look at what happens when we have an active load, such as a current mirror load on a source-coupled pair. So let's look at our traditional source-coupled pair. Here we have M3, M4, M1, and M2, and M5 connected to a constant DC bias voltage. We'll take our input on the gates of the transistors M1 and M2 as usual. And we can show with a similar derivation to the resistive load that our offset voltage, in this case, VOS is equal to delta VTH 1, 2 plus delta VTH 3, 4 times GM 3, 4 over GM 1, 2 plus the following quantity, which we'll write on the next line here, VGS 1, 2 minus VT 1, 2 over 2 times delta W over L 1, 2 over W over L 1, 2 minus delta W over L 3, 4 over W over L 3, 4. Times the following quantity, which we will also write in the next line, delta K1, 2 over K1, 2 plus delta K3, 4 over K3, 4. Alright, so the key points to this derivation are we want to minimize the offset voltage as we did in the previous example. And one way that we might minimize the overdrive voltage is VGS 1, 2 minus VT 1, 2 should be small. Looking here, if we make that voltage small, we make the overdrive voltage smaller. And another thing that we have control over, again neglecting VTHs, we have no control over those, but if we make GM34 smaller than GM12, we would also have a better overdrive voltage because this term would get smaller and our offset voltage would get smaller as a result. Alright, so now we're going to try an experiment with audience retention. So, for those of you that are still watching this video, if you look at your exam or midterm number 1, problem number 4, if you change the resistance Rref and make Rref equal to 7.5 kiloohms and resolve the problem, if you turn it in, you can earn up to 5 points of extra credit for turning the problem in and getting the answer correct. And with that, we will end the lesson on offset voltage and start looking at different operational amplifier topologies for higher gain, and also start looking at the phase response and stability of operational amplifiers in the next few lectures.